Hi guys, yeah, once again, welcome back to the thin class of operating system concepts, and here I'm going to discuss the topic about process synchronization, right? And in this topic, I will just discuss about the programming concepts. So something like the session will all be dedicated towards the sample programming concepts and all the example programs. Okay, and before going and beginning the session, let's start with the short humor sensation, and it says okay, a boy something is saying something like this, it's easier for to pick up a girl of weight 45 kg, but it's quite difficult to pick up a gas cylinder of weight 14.2 kg. It's very strange and true fact, right? Okay, after this humor sensation, okay, let's begin the session. And the session consists of all the programming examples, and in the example 1 we discuss about mutual exclusion by means of semaphore implemented with the pipe. And what is a pipe? Pipe is something that helps in inter-process communication, right? So we are just using the pipe to implement the semaphore. And how do we do it is it's shown in the program. Okay, let's go to the main function and let's check out what it is doing. It is declaring integer variable. Then for the mutual exclusion variable, it's just trying to make a semaphore, right? So if you go and check out the main method, like this semaphore method, okay, we have a make underscore semaphore is the method. And in this method, what is it is doing is we have a semaphore, the semaphore variable, and what it is we are doing is we are allocating a memory for two semaphores. Okay, that's why we are using calloc for two semaphore and the size of an integer, because the semaphore is the type integer, okay, is created. Then after that we pipe these two semaphore that we created so that they can communicate with each other, these two semaphore processes. Then we return this newly created semaphore. Now secondly, we signal out the semaphore. That means we just set it free. As I already told you before, if a semaphore can only consist of positive values, it cannot be negative values. And semaphore having a value equals to 0, that means the semaphore is occupied. Whereas a semaphore having a value that is 1 means or positive value, that means the semaphore is very free or available. Okay, we signal out two semaphores, and then after that we create the processes, 4 kind of processes in a loop with condition check I is less than 4. Then initially for each process, for each index, we execute a process, this function, we call this function process. Now let's check out the process. This process function, what it is doing is it is looping forever, and it is waiting for the semaphore, because as I have already discussed before, while we are using the semaphore, we have to implement by using 2 kind of semaphore primitives that are wait semaphore primitive, and the second one is signal semaphore primitive. For wait semaphore primitive, what it does is it waits for the semaphore so that it can start its action, and it can, by utilizing the semaphore, it can enter into critical region. Okay, so it waits for the semaphore and it enters in the critical region, and now it prints out that it is entering the critical region. Okay, then after it sleeps for 2 seconds, and after that it prints out that it is exiting the critical region. Okay, now what it is doing is like it's signaling out the semaphore, and lastly it sleeps for 1 second. Okay, now this is done for all the other processes. Sorry, you can check out here, like the process for each process, like process I. Okay, for each index it is entering in the critical region and printing out the following statement that it's entering and exiting, sleeping for 2 seconds and then exiting, and lastly it sleeps for 1 second. Okay, we can check out by compiling and running the program. Okay, now let's try to run compiling. So this is the C program for this particular example I was talking about. Now let's compile and run it. When we try to compile and run it, you will execute certain concept, like first it is entering in the critical region of process index 0, then it is entering the process for like critical region process 4. Okay, then it is exiting the critical region 0, and again it is entering process like 2, then it will exit process 4, and again it will enter. So this is continuing, okay, for each all the index like till. So this is keeping on running for forever. It will keep on run forever. Okay, so this concept is used here. Alright, now let's close this program and let's check out the second example. This second example is about alarm clock signals. Okay, and what it is trying to illustrate is the use of system calls, signal, alarm and pause. And before going through all these things, let's check out the main function. What is it doing? In the main function, this is the main function. What we do is firstly we declare the index like integer. Then the signal system call is also called here, and it just sets the handler, sets a signal handler, that is a catcher. Okay, handle to the signal. Okay, so it's a function to handle a signal, that is sets the handler, and the handler is a catcher. So if you go and check out, you can see immediately that there is a catcher function, and this is a catcher function. And inside the catcher function, this handler, what we do is we do the system call date, then immediately after we print out the boiler, and similarly we check out the following condition. If the index is 1, then we just set the handle to the catcher 1, set the alarm handler to 1, whereas if it is not, the index is not equal to 1, that is index is I is not equal to 1, that means it sets the signal handler to the catcher itself. And then similarly the index is decremented with 3, like itself with the 3. Okay, that means it is swapping itself. You can check it out. Now similarly like you can check out the while it is true forever, then it will schedule the alarm for 5 seconds. This alarm system call is called, then it prints out that waiting is begun. So before doing all sorts of things, before checking out the signal, it will have to, it first does is it sets the alarm for 5 seconds, then prints out that waiting is beginning, then pause. And this is one of the important method. What it usually does is it do not proceed, so this function will let all the other signals to be handled before proceeding further, before printing out the end wait. So all the signal handlers will be handled here. Okay, and the signal handlers, all the signal handlers that we have used here, like signal, this will be handled all in this pause. Then after lastly it prints out the input. and it exits. Okay, so catcher 1 is something like this. It also calls the system called date and prints out that here I am, and similarly it checks out the condition, and if the index is 1, then it just calls the system handler itself, then either it calls the next handler. Okay, now let's check out the program with the let's compile and run and see what is happening. This is the program that is boiler alarm.c. Now when we compile and run, as I have told you, like the waiting begins, waits for 5 seconds, then immediately the system call wait, like date is called, the date of today, then boiler, the handler, catcher, okay, is called, then it ends the waiting begins, then similar system called catcher 1 handler is also occurring there, and similarly it keeps on going forever. Okay, so this is the situation. Now for example 3 is like we are doing is like the scheduler of process running at a fixed interval of time. So what is doing is we are trying to use the program is doing is scheduling the process running at a fixed interval of time. This scheduler with semaphore. And the program goes like this. Okay, going into the program, let's just check out the main. We'll first initialize the cellular. Okay, these are something like interval. Okay, with the index. If we go and check out here, we have defined as a global variable the interval with the maximum size, that is np rock. Okay, whereas also deadline is also defined here. All the global variables are defined outside, and if you check out here, it is first initialized the scheduler, the interval and the deadline. You can also check out the clock, make semaphore is called, and if you check out here, the make semaphore just does the same as before, like it makes the semaphore. Okay, then it pipes these two semaphore together and it returns the semaphore. The array of semaphores are created here. You can check out. Right? So after that, similarly for index 1, we make semaphore for clock. For also semaphore 1, we make another semaphore to initialize with the another semaphore. Then we create the children for each children. Process 0 is called. This process 0 function is called, and for second child process 1 function is called, and lastly the failure function is called for these children. And you can check out all these functions. Process 0 is this one, the function. Just is I am process something, and system called date is called. Okay, it waits for the semaphore, then particular just print out the statement, then it just prints out the date. Whereas also for process 1, it just print out the process ID, like process, which process it is, and then also the similarly, like you get the process ID here. Process ID, the following process ID is printed out here, and also calls the date. Right? And also in this failure function, we just like set the signal handler, like alarm handler, that is a catcher. This catcher just prints out talk, like tick, and just print out the date. Okay, and just calls the same signal handler. And this is all done here in the pause, because pause do not proceed and it lets all the signal handler to call itself. Okay, and alarm first set the alarm to 1, then the pause is called. Now let's check out the situation in the program. Okay, this was the scheduler. Let's see. Now let's remove this previous program. Let's try to compile and run. And as I have told out, first tick 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 until the time is printed out. Wake up the process. Okay, with PID 0. Okay, at time 5. Okay, and the clock. Okay, so system call, clock is called. Then as you put like tick tick, wait for 2 seconds. Then process 1 is called. Okay, with identify 1. Same time. Okay, everything is. It is keeps on calling. Okay, this was just the simple example for using semaphore for managing processes, synchronizing processes. Now let's go and check out another thing, that is a POSIX semaphore. What is a POSIX semaphore? POSIX semaphore are something like that allows process and threads to synchronize their action. Means processes and threads are synchronized, okay, by using POSIX semaphore. As I have POSIX thread, that is P thread, right? All the purpose was thread was just to help in concurrent programming, like cooperating processes, right? It has to create us cooperating processes to perform the particular task. Now there are some particular examples for this kind of synchronization for Unix threads. This is not a very this is just to conceptually understand and visually see like how the process runs. Okay, it is not like the students are not like asked to just know this all by detail in a very deep concept. This is just to understand and see like how the situation is going around in the programming. But programming is like very like here we are using all the POSIX system calls and everything just like that. I just suggest you guys to just try to understand and see it. Okay, try to understand. It's not like you have to just learn by heart the situation. Okay, now this is mutual exclusion by means of mutex in example 1. What is done is like you can check out. Okay, let's go to the main function itself, and what we do is like int status variable is declared. Pthread, this thread variable is declared, right? You already know that the thread variables are all declared by this type pthread underscore t. And set buffer. Okay, like what we have to understand is like these two situations. This status is initialized with pthread create system, like this pthread create system call is called. This creates a new thread, and similarly in the status second pthread, next pthread create is created, that is that calls this handler function mutual exclusion any underscore thread handler. Okay, and whenever there is a, and lastly the thread is executed. Okay, thread termination occurs here. This is inside the main function. So now let's check out this handler. Okay, what is happening? Pthread, in this pthread handler, what is happening is like first we detach the thread. Okay, and pthread self is occurs. So what pthread self does is it obtains the ID of the calling thread. Okay, and wherever the status is not equals to 0, that means the ID that the pthread is detaching. Okay, detach the thread. That the ID that is this status returns is not equal to 0, then we said that detach. There was an error. Detach thread. Okay, error exception is handled here. So wherever for loop, we also do the mutex locking. Mutex lock just locks the mutex object referenced by the mutex with this mutex variable. The address is passed here, and this just tries to lock the mutex object that is passed. Okay, and Similarly, the second situation, it just also tries to unlock it. Okay, after it reaches the critical section, that is critical region of thread, it first locks the mutex variable, then it print out the statement that it has entered the critical region of the thread, okay, and the pthread itself that obtains the ID of the calling thread, and lastly it just unlocks the mutex variable. Okay, and sleeps for 2 seconds. Okay, these are the things. So now let's check out the situation in the program. Okay, to run the, as I have already discussed before, that to run the C program with thread, we have to include the thread library. So we have to use a terminal to compile and use in GCC. This mutex.c file is in this location. So let's go and check out the location first. Okay, it's in desktop. It's in operating system. And after in operating system, I have programs. And the programs in the subfolder thread. I have already execution file, so you can directly execute, or you can, okay, let me first delete this already executed. Okay, there is no more. Now my file is this mutex.c file. Now let's try to compile and then compile including the library, and then we'll run it, execute it. Okay, just first create the executable file. GCC, the file name is mutex.c. okay, so create the object file of this the execution file of mutex, and include the library like pthread. Okay, if you go and check out, this mutex executable file is here. Now let's just try to execute this. Look, you can check out the thread, critical region of thread, and with the identifier of the thread is printed out 68 and 64, 64, 68, and 68, 64, 64, 68. Similarly, it continues to print out forever. Oh, sorry. Okay, let's clear this. This is about for this first example. Now I just strongly suggest you guys just to conceptually understand this. Okay, this is not a very just try to get an idea of how this is running. It's not a very strongly important question for the exam. Okay, we are not allowed asked to create some threads or try to mutually synchronize by using mutex and try to run out and prepare a C program to run in the examination. Okay, this is never asked, but just try to learn and observe the situation, what is happening. Now in the second example is about mutual exclusion with mutex testing, and it's the same situation. It's a very lengthy program, and okay, let's go to the main program. I'll just try to give you the brief idea. the clear idea you have to understand always is like pre-thread create. The thread is created here. Okay, the handler is whenever you create the thread, the handler is called, and if the exception occurs, then it is handled by this error abort handler. And similarly, you just create the second thread that with the handler monitor thread. First, the counter thread handler was created, called while creating the thread. Then, secondly, the monitor thread was created, right? And similarly, we handle the exception. And lastly, we just try to join the thread, and we handle the exception. And similarly, first we try to join the counter thread, then with this counter handler, then the monitor thread. And similarly, we handle the exception, exception occur. And if you go and check out all these handlers, the counter handler and the monitor handler, that is the monitor thread, right? And what is the main part of counter handler? What it is doing is start routing, that is repeatedly locks a mutex and increments a counter. What is the counter thread is doing, this handler is doing, is just counting or incrementing the counter. Okay, locks the mutex. First it has to lock the mutex, go to the critical section, then look. First it locks the mutex locks by calling this system called pthread mutex locks the particular mutex variable. Then it goes to the critical region and performs this action, that is counting, incrementing the counter, and lastly it unlocks the mutex after performing the action, right? So this is done in counter thread. Whereas if you go and check out the handler, that is a monitor thread handler, the thread starts routing to the monitor the counter every 3 seconds, try to lock the mutex and read the counter. So what it's doing is just reading the counter, and if the try lock fails, skip the cycle. Okay, so same thing is going up, and first it sleeps for 3 seconds and performs the try lock, means try to lock the mutex variable, and tries to read the counter, and lastly it unlock the mutex variable. Okay, and this exception is handled lastly. Okay, let's try to run the situation and see what is the situation here. It was already about our try lock. That's it. I already create the exception, the execution file, so let's try to just execute it. You can see the counter is 3, it sleeps for 3 seconds, and counter is 6. Similarly, it increments by 3, so counter is 9, 12, means it's sleeping for 3 seconds. The monitor is sleeping for 3 seconds and then it is reading. That means the counter is keeping on incrementing the counter. It doesn't stop, but the monitor just sleeps for 3 seconds and wakes and reads, so it prints out just 3. Then it sleeps for 3 seconds, then it reads, it prints out 6. So similarly the situation is going around like this. Now let's stop this cycle, then let's go to the second example. No, this was the second example, right? Let's go to the third example, image management with conditional variables. Then how conditional variables, by using conditional variables we demonstrate the simple conditional variables weight and something like this. Let's directly go to the main function. What is doing is similarly the important concepts that you have to understand is always go through the create. and wait thread the handler is called here. Just this concept you have to understand. Then okay, we handle the exceptions here. The thread tries to lock the mutex variable. Okay, it performs the action. Status here. And so lastly it unlocks. This locking, you have to always be careful about locking and unlocking the situation. Okay, the status is locked here, so that the mutex variable is locked here. Data, the mutex, the semaphore is this data.mutex. Okay, and it is locked. And lastly, it is unlocked here. That means between this it goes to the critical section and then performs the action. So while data.value equals to 0, okay, condition is time wait, okay, wait on condition, and lastly is the data value. That value is not equal to 0, then condition was 0. Let's try to read the argument from the input output. Okay, this author. Yeah, this wait thread, like you can check out. You guys get me? Like wait thread, yeah. When you create the thread, like wait thread handler was created, and this wait thread handler is just described here. Whatever it does, it's like locks the mutex, signal the condition, and unlocks the mutex. Okay, threading is done here by using the respective handler. Okay, now let's check out the example in the terminal situation. Where is the name of the example file is con.c, condition.c. Yeah, we already had the executable file, that is con. So let's try to execute it. Yeah, condition was signaled. That means everything was well. There was the variable was not equal to 0. Okay, the data value was not equal to 0, so condition was signaled here. So this was the situation inside the critical region. Okay, just be careful about like this. These are the important concepts. All the actions is performed between this locking and unlocking phase. Okay, now the third example. No, it was the fourth example. Now the last example. It's the last example about consumer and producer problem by using the mutex condition. And similarly, all the integers between 0 and 999 should be printed exactly twice. One is in the right and one is on the left of the arrow. So let's see what it is doing. Yeah, look, it creates the thread, calls the producer handler, which handles the producing. Okay, where that is on the right side of the arrow. Okay, like look, the right side of the arrow in this side. It's on the left side, I mean. Whereas there are consumers, and like you create the pre-thread, you create a second thread that is a consumer thread that calls the consumer handler, and this is the consumer handler, and it is printed out in the right side here. Okay, and this is the situation here. And lastly, we join these two threads together, and lastly we return and execute. Now let's check out the example. Okay, this is the executable file of the program. Now let's try to execute it. Yeah, you can check out here. Look, all the producers were printed out here. 900 till 999, right? 999 producers were created, and on the left side 999 producers produced, and on the right side 999 no 9999 producer items were produced by the producers, whereas 9999 produced items were consumed by the consumers in the right side. So similarly, check out all these were printed out, right? So sorry for some kind of pausing situation, but this was just to show you visually and conceptually, make you understand and see the situation, what is going around. Okay, it is not needed to understand or go through this programming concept very in detail or bit by bit, but just getting the observation and seeing how it is going around is also, it will give you some kind of idea and concept to understand much better and later on about object or operating system concepts, about fundamental concepts about these threads. Okay, now okay, thanks for listening, and see you in the next lecture.